How's it going? Hello.
Mm.
Right. I am not seeing my slides at the moment. I'm guessing they're just going to be popping down in a sec. Ah, there we go. Let's do a quick check. Forward, backward. Lovely. How's everybody doing? I am keeping an eye on the chat on the live video over on YouTube. So if anyone wants to drop any messages, I absolutely encourage anyone who wants to say something silly, ask a question, anything you like. I'm keeping one eye on it. So hello to the 18 people currently online. So let's have a quick start then. This is me. This is there's my contact details in the unlikely event that anyone ever wants to talk to me again after this. So I'm going to talk about functional programming in C Sharp, and this is the super duper updated version. We're going to be covering up to C Sharp 9, which is marvelous. Because why should the functional languages have all the fun? I'm a .NET developer. I want to be able to play in the functional play park as well. A little bit about me, if anyone's really particularly interested. I've been developing for about 16 years, give or take. I've worked for a whole load of companies, including some government stuff. I've done work for The Works, that's a great big bookshop in the UK. Briefly, I was one of those contractors that your mum always warned you about when you were little. And at the moment, I work for Muller. That's the dairy company they are known in the UK mostly for some rather delicious brands of yogurt. Unfortunately, I started working for them after lockdown, so I have not yet had the free yogurt I was promised when I get to go into the office. I'm still waiting for my yogurt. I like yogurt. Right, moving on then. So, first off, a bit of good old-fashioned, totally not functional whatsoever C# code, and this is nothing terribly complicated. Incidentally, you may notice some references to certain science fiction TV series and films. Anyone who cares to jump out and notice what they are gets bonus points and no prize whatsoever, but it still makes you cool. So this is parsing a CSV, splitting it up again, and then dumping it into some sort of system where we're deciding whether we want to display based on how well I personally rate it. For anyone, by the way, this is the popular British TV series Doctor Who. These are the first episodes ever made back in 1963, because I like it. Right. And this is how we do it functionally. Now, anyone who knows C# to any extent whatsoever might notice that basically this is all link, which, yay, well done, James Dillon. Doctor Who, you're quite right. This is all link, and it totally, absolutely is. It's just link, because link is functional. Link is absolutely functional. It does not modify the original. It creates a copy, which it passes back. It requires functions as parameters. It's functional programming. And this isn't, of course, any sort of a coincidence. There is actually, so far as I'm aware, a policy on the C# team that they want every version of C# released to be more functional than the one before it. I don't know how exactly it all started, but this is all part of the relationship they have with F#, which of course requires an awful lot of stuff to be able to do its properly functional programming, and C#'s basically benefiting by having this stuff along. The intention is that C# will be a hybrid language. It's never going to be pure functional, but it's always going to support the functional paradigm along with the object-orientated and, sure, I suppose, the procedural if you really want to. But yeah, absolutely. And that's kind of as simple as basic as it gets, doing C#. There we go, use link. But obviously we can take it an awful lot further than that, because otherwise this would be a terribly short talk. Here's an example of a structure that I can more easily render into a functional form with a little bit of tinkering. So this here is a set of rules that I got very used to working with back when I worked for Inland Revenue here in the UK. And these are rules for parsing a Nino. Nino, for anyone that's not aware, is a national insurance number. We all have to have them here when we work, and it's got a long set of rather arbitrary rules that tells you whether it's valid or not. And if you do it in the non-functional style, it's long, it's complicated, it's got a lot of repetition. But we can do it in a slightly more functional way if we play around a little bit. So, first off, something that not everyone realizes you can do is you can stick funcs in an array. Now, at this point, anybody shout out over on YouTube if you don't know what func is, because if you don't, going to be an awfully long talk for you. But in brief, it's just a function stored in a variable. But so you can stick these things in arrays, though. And once you start to do that, you could do an awful lot of clever things. So I've given these things names just because I like to be verbose, believe it or not. And I'm sticking them in an array, and then I'm calling a link function. And the link function is all. All means go through the items one at a time, and then do whatever the heck is in the function I'm passing in. This is another higher order function there. And what it's saying is replace out any spaces with nothing. So we're just compacting it down into the basic characters of your Nino, your national insurance number, and then stuff that into each func in turn. All of these funcs turn a string into a bool. The bool is, are they valid, are they not? And the string is the input parameter. So the way that all behaves is it goes through one at a time. Every single item must return true. So every function must return true, and if they all return true, the whole thing returns true. But if any one of them returns false, then we kick out early. We don't bother to execute the rest, and we just return a false. So this entirely replicates the whole rest of that big block of code you saw, plus some extra bits, and it's more verbose, and frankly, it's easy to maintain if the government were to arbitrarily throw in another rule, which they could, and all of this is nice and functional. So a little bit of creativity, and we can absolutely expand the paradigm out, the functional style of programming out. And in fact, we could even go and tinker out. This is an extension method. Again, please shout out if extension method is something you're not familiar with. But I'm using params, which is one of my other favorite features of almost any programming language, to save myself an awful lot of time to just give myself a slightly nicer looking function which attaches actually to every single item in the whole of C#, because I have extended this on a generic, which means everything now has a function hanging off it called validate, and then you just give it a series of arrow functions effectively, and it will validate it based on those rules. Woo! And that has saved goodness knows how much typing of boilerplate code that you'd otherwise have to write. I certainly have worked in one or two code bases that would be probably about the quarter of the size they are if we use this sort of technique. And I'm a big fan of lazy programming because, frankly, I'm really quite lazy. Another functional structure, I have heard these things called all sorts of things. I'm aware I'm talking to functional groups. I have this horrible feeling that someone at the back is going to say, actually, I think you'll find that's actually called, or whatever, I don't know. But alt is the name I know this by. So what is alt here doing? Alt is saying, here's a series of operations, and you're going to go through them one at a time until one of them actually returns something useful. And here in my hypothetical example, I've got the first one, which is, it's actually a func. I mean, really, we're going to have to use a little bit of imagination. In the real world, these are like, I don't know, the first one's a database operation, the second one's some sort of fallback flat file operation or something. But a bit of, yeah, you get the idea. But the first one here returns null. The second one returns something interesting. It's a string, as it happens. In the real world, it'd probably be a record. And it's just saying, okay, run the first one, that didn't work. Run the second one, that did work. So actually, this will output here will equal a string, even though the first item there will return a null. And how does that work behind this? Why am I using my keyboard? Because I have to use my phone. There we go. That's how it would look. Little bit of ugliness here. This is unfortunately the way it goes with some of these funky little extension methods I'm writing, but still. I've written two here. The bottom one looking at is the first one to look at, if default do. So what I'm saying is attached to everything, and we're going to have an else statement, and that will be run if this, whatever this is default. Now, it has to be called default because integers do not default to null, neither do booleans, neither do an awful lot of other things. Most things do, some things don't. We're working with generics, so that's what this great big equality comparer thing is as well. That's just a generic way of dealing with null. So what I'm saying is if it's null slash default slash whatever, then run the else function. If it's not, then whatever this is good enough. And then the alt function up the top there is saying first run f1, whatever function 1 is, stuff the initial input parameter in, and then call if default do to say, did it return null? Yes, no. If it did, then have another go. Wait. And we could probably extend this practice out with the params and do all sorts of other interesting things too, but you get the idea. It's another sort of functional structure that's going to allow us to do an awful lot more with an awful lot less code, which is yay. Oh, there we go. Fork. So this is one of the stupidest examples I could possibly imagine of a fork, but I'm keeping it simple because I don't want to get too bogged down in detail. And frankly, you could probably do this without a fork, but I'm just trying to demonstrate. So fork, for anyone that doesn't know, what we do is we take our initial input, we do several processes of it separately, returning the same data type. In my case, it's an integer because I'm doing counts. And then up the top there, we've got a function which will stuff it all together. So the first thing there is the joiner, the sum, and the other three are the prongs of the fork. Now, again, you wouldn't necessarily do this exact function. I'm just keeping this really incredibly simple, but there might be other ways that you'd want to apply several different processes to the same function and then stuff it back together again. And this slightly ugly thing is how we're doing it. I'm using map, which is one of the very simplest monads you could possibly imagine. It is literally just attached to everything and then take a function that turns old thing to new thing. It's just for the sake of keeping it compact. I like using map. And it's just really a very simple select statement to select out this, whatever this is, the initial input, into an array of whatever the new output type is, and then pass them into the join function. Dead simple, frankly. So that's it. It doesn't have to be complicated at all. Now, this looks quite ugly, but like a lot of these things, this can go to the back of your code base somewhere where you don't really need to worry about what it looks like. You just need to be able to use it. So let's move on to another facet of functional programming, because we've done the structural stuff. Now let's have a look at some pattern recognition and how we can go with this, because this is one of the more exciting areas of the recent developments in C#, because as of C# 9, this is really cool stuff. So this is the sort of example you tend to get in the textbooks. It's a bank account. So I got a standard bank account, which has got a balance and an interest. I got a super duper bank account, which has got some sort of bonus interest rate, and I've got a dodgy bank account, which I don't know, it belongs to, insert the name of a politician here that you don't care for. I don't want to know who, but we can all think of one. And it's got a brown paper bag of money, probably passed in a car park or something. I don't know. And we want to apply our interest rate. So this is going back a few C# versions. I think this is accurate as of about C# 6 or 7, something like that. But this is still an awful lot better than anything you could ever have done in previous versions of C#. So the things to look at here, we're switching on the bank account. We're switching, in fact, on the base class, which is, I think it's just standard bank account. And we can then switch on which subtype are we actually faced with, which is the real type. The first one is the dodgy bank account. And not only that, but you can place a local variable there just after the case, and it will automatically retype DBA there into being the correct type for us to actually access the properties of the child class, and then use those to calculate our proper interest. And then we've got the same with the super duper one, but then also we can do something special with the standard. We can do an additional clause, a when clause, based on the properties of the account as well as its type. And this, for just this as it is, saves me so much flipping boring boilerplate code that I had to get used to writing previously, and just don't have to do anymore. We don't have to do type checking. We don't have to do stiffing of one type into another. It's all kind of just done for us in a nice, safe, easy form. It's really cool. But C# weren't so content with just sticking with that. We can go further as of the latest versions of C#. Now, first off, switch is now a function, which is awesome. We could just turn the whole thing into a flipping arrow function, and that's really cool for a start. And have a look inside there. We've now got instead a list of arrow functions. It's a little more compact. We don't have to bother with our breaks and stuff anymore. But on top of that, we've got a much nicer syntax. Look at the third and fourth line there. We can now use this sort of vaguely JSON-like structure for making selects against properties of the object. Much nicer to look at. And I believe they, as of now, they're working on enhancing this yet further for later versions of C#. I think I think I read somewhere that there's a little bit of dodginess if you start going into like sub properties of objects. But I think that's something they're working on as of like C#10 or so. I don't know when that's coming, but it's coming. But this is an incredibly powerful syntax, and I think it's somewhere vaguely near comparable to the sorts of things you can do in F# and similar. And it means that us in a C# will get to play with these toys too, and that's brilliant. Next is a bit of a store point in some ways, and that's immutability. So, can we do immutability in C#? Sort of. So this actually sort of is immutable right now. This is actually an immutable class. So this is immutable because I've put no setters on it, and I'm requiring that everything be put in the the constructor. So yeah, it's a little bit of a pain in the neck to write out to use because you have to put literally everything in the constructor. But fine, this is actually immutable. That's wonderful. This, on the other hand, is not. Same process. I've got no setters. I have put everything in the constructor, but the list is immutable. Excuse me. The list can have items added to it, taken away from it, altered. You can't actually replace it outright, but you can still modify it in and of itself, so this is back to being mutable. Are we playing? Are we playing? Click. There. This is immutable again. So I've converted my iList into an immutable array. Bang. Oh, there's a rogue set there. That shouldn't be there. Just pretend that's not there, please, folks. But this is immutable. If you just stick your finger over that set there that's crept in somehow. And that's fine. That's wonderful. What about now? Now we're back to being mutable again, because this subclass has properties and they're all going to be mutable. So unless we developed it ourselves and wrote it all our own way, so fine. This is you could go to an absolutely ludicrous extent to make every single class look like this, but what about dealing with classes that are coming out of third-party libraries? They're all still going to be mutable, and there's nothing you can do about that. So true immutability in C# is a bit of a pipe dream, I think. There is some stuff that's been added in as of in the recent versions, so we'll come into that in a second, but broadly speaking, immutability isn't really a thing we can accomplish. Not really. I think it's a good idea to pretend that it exists, because you'll tend to write better code that way, but it doesn't really exist in a way that's enforced by the language itself. Now we can do this now. This is moving in that direction. If you notice up the top there, there's a tag, nullable enable, and that just means it's enabling some warnings. So if you start to try and turn anything into null, then it'll put a compiler warning in. I mean, it's not immutability, but it's something. It's giving us something. There. Same here. You can it'll give us warnings if we try to have trinary expressions that could result in a null value coming out, and it's something. It's good. It is good. I'd honestly recommend turning it on. You can even bypass it by either using the exclamation mark or the question mark. Question mark saying only call the function if it's definitely not null. Exclamation mark is saying I don't care, just do it. I'll deal with the explosions when they happen. Not sure if that last one's a particularly good idea, which is why I've personally never used it. And you can use this to turn it on in the whole thing. It's the nullable tag you see there straight after which version of .NET you're using. So yeah, that's cool. That is cool, and it's probably something I'm going to start using. But honestly, still, immutability is still just not a thing we've got. And I'm not sure it's a thing we're ever going to get either, because one thing I believe the C# team are quite keen on being concerned with is backwards compatibility. And if you suddenly make everything in C# immutable, well, that is going to break nearly every single C# program that exists in the entire world. So it's probably the reason we're never getting it. And yeah, that's another thing we can do. We can put init. This is new as of, I think this is a C# 9 feature, and that's to use init instead of set, which means it's a slightly better version of what I wrote previously. It means that you can still use the anonymous constructor there with prop1 and so on without having to use a constructor. But and if you try there to change its value, it'll just say no can do. But we've still got the same problems of subclasses and the like. That's still an issue, although this looks a lot nicer and it's a bit friendly to work with. And this is an example of a slightly the slightly funkier things we can do with switches. We've got operations we can apply based on. And yes, this is my other. Sorry, my mistake. This is my other favorite thing of C# 9. This is really, 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 really cool, and this does help us some way towards allowing us to be a little bit more immutable without an awful lot of fuss. And that's record types. Record types are like classes, except they're passed around I believe they're passed around by value rather than reference. But that aside, they've got a whole load of stuff that hangs off them, which is really cool. And the one of them is they can be constructed using the with syntax, which is what you see below. So this is my switch statement, and I've created this hypothetical function to update one of the properties of this person here, and I'm seeing what I'm going to do is, rather than have to entirely construct a new one every time, which is what you'd have to do if we're trying to treat everything as mutable. Instead, you can say things like, if I'm changing my first name only, I can say P, that's the person, with first name equals param in that nice little bit of JSON-y format. So what that means is create an exact duplicate of the original, accepting that the first name is substituted for whatever the thing coming in was. And that's really, really flipping cool. That means we can treat much more of our code base as if it were immutable without having to write gigantic grade, create new blah from this, copying over all of the properties one at a time, and having to update that every single time the thing changes. Just no, with, and that does everything for us. That's really flipping cool. And this is one of my favorite features of the most recent version of C#, and something, if any of you guys haven't actually played with it, I'd recommend giving it a go because I love it. So currying. Can we curry in C#? I am hoping, normally at this point in these talks, I have to say, who knows what currying is? I'm hoping that everyone on this sort of a talk is going to know, and no, it is not an incredibly delicious Indian food. It's just applying functions, the parameters of a function one at a time, and getting back a function if you haven't applied them all. Again, if anyone doesn't know what currying then is, the next few slides are going to be a little tough on you, so shout out now in the live chat because I'm keeping one eye, but I'm hoping that it's not terribly complicated for you. Can we do it, though? Can we do it? Ish, little bit. Yeah, sort of. And this is roughly what it looked like. So this is an arrow function that returns another arrow function, in effect. If you look there are two arrows. The first one is so that actually calling one of these functions, add, subtract, blah, blah, will return you another arrow function, which is an int to an int. Now, it could be a double to a double or a decimal to a decimal, doesn't really matter. But what you're getting there is a func back where one of the items is filled in for you already. And you can use this. And what you don't have is what the functional languages have, which is where, like, everything can be curryable. We don't have that in C#. If you want to start using currying, you've basically got to do it yourself almost every time. So I'll be honest, I don't really use this very much. It's nice for a little bit of syntactic sugar, but and there we go. It is a thing that exists. We can do something a little nicer. It's back to my Doctor Who again, because for anyone that's never heard of it, Doctor Who is the best TV series ever made. It's official. If you look it up in the dictionary, that's exactly what it says right there. Best ever. So what we can do is a partial application. This is again, I'm going hypothetical. This is a parsing of a CSV. We are splitting by line, splitting by field. We're telling it which field we want out of the whole thing, and then finally passing the actual string that needs to be converted. I've put in some new lines here just to make it readable, but in the real world example, this will probably just be one great big long flat file, and that's lovely. So that's down there as a func. I'm passing this func out. It's got 4 parameters, those being like the line splitter, the field splitter, the field I want, and so on. So if we wanted to split this out into something that we could reuse and reapply many times, which is of course what the whole point of currying and so on is, then that we can. There is a way. It'd look kind of like this. So use an extension method, which I will explain in a moment, called apply. So with apply, I am taking the whole thing with 4 parameters, and I'm applying 2 parameters to it. I'm passing a new line and a comma. So that will get me a parse function, and the parse function is something that will take any string and a field, and it will split that entire string based on new line, and then split on fields based on comma, which is not unusual for a CSV, and then I could create a couple of different functions out of that. I could give it pass a 0 into the function that's come back out of that, the parse function, and what I've got is a function that will split a CSV up and then get me the first item out of it, which is the serial codes, because every Doctor Who story from the classic series has a code like that, the letters of the alphabet. Or you could pass something else. So down there, 1, and you could get just all the story titles extracted. But the point is that I've created 2 fairly complex functions, but I have only ever actually had to write 1. And the rest of it is just a matter of passing in parameters to specify how exactly to construct the function. That's pretty cool. We can do this. It looks like this. That's ugly. I'm not going to lie, that's pretty ugly. And it's basically turning an extension method which applies to any func with this many parameters, returning another one with this many, taking the parameters that have been filled in and then stuffing them in, and it's doable. It's basically like a wrapper around your original func, which sits there and acts as a filter and applies things as needed. And to do this, you would have to write one of these for every combination of how many parameters going in to how many going out. So you'd have to write a lot of boilerplate to get it working, but once you've written all the boilerplate, it's there. And of course, I believe it only works on params, on funcs. So you'd have to make sure that you store the stuff that you want to partial apply as a func in order to convert it as you wish. So it's a lot of hacking around, to be quite honest, but it can be done if you're desperate. So moving on to the final part of the functional flow. So this is your kind of standard functional flow. We'll start with a thing. We'll do some filtering. We'll do some converting, and then finally we've got to aggregate down into a single answer at the end. How do we? This is the sort of thing that it astonishes me on a regular basis that most people don't know has been in C# since about C# like 2 or 3 or 4. I don't know. So this is turn a whole load of items into a single string. So I'm making it the episode titles of the first series of Doctor Who, and stick commas and new lines and all this sort of thing in between, with an additional if to say, well, make sure that you don't stick a comma on the last one. Or actually, you could just do it like this: string.join. Why does no one know this exists? I don't understand, but there you go. String.join, lovely. It's one of the best functions in all of C#. That will literally just stuff all of the separate strings into one, with this stuffed only in between two existing strings. It's great. But anyway, that's a little bit of a cheat. How do we do something a little bit more sophisticated? Here I am going to go with a database again of the first series of Doctor Who. If anyone gets a chance, watch the first Dalek story. It's very, 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 very good. And here's some data. So I am going to say that I want to aggregate these into something a little bit more meaningful. I want to create a report maybe, or just show off on what my favourite stories are. Now there is a whole load of built-in aggregate functions in LINQ. You can see them being demonstrated here. There's sum, which is literally like to give me a higher order function, and then whatever the result of that higher order function is, take all of the answers from each run and add them all together. I've got average, which is the same, again, requires a higher order function, turn all the results into an average. So, wait, that's all nice and easy. But what if we want to do something more complicated? And this is one of those, why does nobody know this exists? But it does. Aggregate. Aggregate is basically the function that underpins all of those other guys. This is writing your own custom functionality for an aggregation. And so I'm starting, in fact, with a tuple. And a tuple is something that's worth knowing about. This is brilliant if you're writing functional flows. A tuple is just like a little throwaway cluster of data. So here it's an int and an int. I'm starting it as 0 and 0, and then I have to give it a function which takes the current value out of the array and the accumulator, that being the running total so far. So the running total so far starts as the previous, that's the seed value, 0 to 0. And then for each run, I am saying to the accumulator, add to the first item, the number of missing episodes, because there are missing episodes of Doctor Who. There are 97 to date. If anyone who's listening to this happens to have one, do please let the BBC know, because I would quite like to see them again. And the number of total episodes, so I can turn that into a percentage now. This is fairly trivial stuff, quite frankly, but again, I'm just demonstrating what I'm doing. And there we go. So you would just run that function, would be run against every item in the array, and give us a grand total, which would be a tuple. And then out of my tuple, I can do whatever calculations I want to using math.round. So there's no need for any of this for looping and all the rest of it. To be honest, you never actually need to use for loops, for eaches. Frankly, you don't hardly need to use if statements again in C# if you don't want to, because there are structures you can use as alternatives, structures that respect the functional paradigm, and frankly are a lot easier to work with. So moving on to the last bit, this is a topic of conversation that came up an awful lot when I worked for an American company. I'm British, of course, and it is a bit of a cliche that we like to talk about the weather, and it's frankly mostly true. We do. We really, really do. So I would ask my American colleagues what the temperature was, and they would say, I'm not doing the accent because I can't, that it's 100 degrees. And I would say, my goodness, 100 degrees, that's hot enough to boil water. But then you'd have to think, yes, that's Fahrenheit. So the process for converting from Fahrenheit to Celsius is deduct 32, multiply by 5, divide by 9. Of course it is. Yay, why wouldn't? Yes, absolutely. And that's the process. You'd have to take one value and then apply a transformation, do a thing, apply another transformation, take that value, and so on and so forth, and then I'll round it and then wrap it all into a string. And yeah, hopefully one or two of you will see where I'm going with this. Or we could use a functional structure. We'll call it identity for now. Identity here, and I'm using a generic. A generic means I can stick anything inside this. Identity here is just a box to put a thing in. It's a thing in a box. And value is my thing in its box. I've used a couple of implicit operators down there for a bit of syntactic sugar so that I can not have to bother actually calling this the dot value to pull it out and stuff like that. So, because I'm lazy. Did I mention that? And identity here can have some functions extended from it. So first off, we'll attach a extension method to everything, T generic, that's everything, and that will mean that it's easy just to call toIdentity off of everything, and then bind there. Bind is just the same as map. So bind is saying if you're an identity, you can use the bind function to give a function, and the function will describe how to transform the old file, the old data into the new. It's just a transformation step, and it can be anything to anything because I've used two generics, and then call back an identity of that which has the old value, the new value stuffed into it, and I'm taking the value out of the old one as the input to the parameter. That took me an awful long time to say, but that's what it looks like. Same exact thing. Same exact thing. I am just a series of steps. Each one takes the old value out of whatever it was, runs a function against it, and look, there's my curried functions. I see I do have uses for them. Run a transformation. So I'm doing a subtract 32, multiply 5, divide by 9. And there we go. That will actually output finally a string which is formatted with the correct transformation ultimately applied. So this is a monad. For anyone who probably, I'm talking to an audience of people that already know all this sort of stuff, but this is a monad. And this is how you implement one in C#. So we could do that too. We can. It's just you've got to hack around a little bit to make it work. Now here's a slightly more complicated one. This is the maybe, and the maybe is the one where it can return something or not depending on whether a previous step works. And this one actually will come null because I've created a function here which I know will be null. But what we want is for those string replaces not to fail, because of course that's exactly what happens if you try passing a null and calling a property of it. So the maybe is how we do that. And this is what a maybe looks like in C#. A maybe starts with a base class, which is abstract, and that's because we don't actually ever want to implement it. We just want to have the two subclasses. The subclasses, now I'm calling this is the one where there's something and the one where there's nothing. Now I could call them something and nothing. I've heard them called just, I've heard them called honestly all sorts of things. I've heard them called option. They've had loads of names, but this is as good as any. But we've got two subclasses. The one where there's something inside it and it worked. The ones where there's nothing inside it and it didn't work. The best description I've ever heard of this process was from Scott Vlashin's website. I think it's F# for Fun and Profit. Very good website. Recommend checking it out. And he described it as being railway-orientated architecture. His description was that you imagine that you've got railway tracks running in parallel. There's the top one where everything works, and there's the bottom one where nothing worked or something didn't work. And every function is a point going from the one track to the other. And the idea is that if a single point fails, as in one function failed, then we switch to the it didn't work track and then just coast into the station without doing any further work. And that's exactly what this does. It allows us to define a single train, a single path, but then if something doesn't work, we don't have to start putting all those branching if statements that end up looking like family trees. And that's what that looks like. It's mostly the same. Except our bind is now more complicated. We're having to do a switch based on, there's that slightly scary looking equality comparer again, but it's just checking was it null. And we're putting a try catch in so that means that if we get a null back, if we get a null, or if something fails, then it's fine. It will not fail, it won't crash out, it'll just return a nothing class. So then that's the signal to the thing at the end that it didn't work. Otherwise, if it does work, if it did not fail and it did not return a default, then we get a new something, a new just or whatever, and that is returned as a new maybe. So we can carry on the process. You could also return this out of a function. If you return a function out on an interface with maybe tag around it, it effectively means, I don't know if this is going to work or not. You've got to judge when you receive it, and you've got to know what to do. Others are slightly more complicated, and this is actually what I'm more tending to use in production when I do, and that's the left again is everything worked. Sorry, the right is everything worked, and the left is it didn't work, but I'm also carrying things like exception as in if it failed with an error, then I can return out the exception and push that down to the end so that I can handle the exception or report it at least. In fact, to be honest, in production, what I tend to do is create 3 states. I tend to create it worked, it didn't, I got null, or there was an error, and then have a handle for each case using one of those new funky switch statements that you saw earlier on, so that you can do a nice graceful handle of whatever happened, and then you can use that to determine what to return to your web API or your whatever. And it's nearly exactly the same. That's your to either, and and it's now got 3 states to handle, and one is we got a null, which turns into a left, or we got an error, and we can capture the error and stuff it inside. We can do all that stuff. Come on. There we go. One question I get asked a lot: are there any libraries that you can use in C# that already implement this? The only one I'm aware of is LanguageExt. It's pretty good. I have had a little bit of a play with it, and it seems reasonable. Frankly, I personally, because I like learning this stuff, I like to implement it myself. And there's all sorts of ways you can have I've got a common little library that I pass around from project to project, and I think it's just nice to get a feel, because part of this, what's important with this for me is I want to really understand the principles behind the functional structures as well as just using them. So I like to roll my own, as it were, so that I can understand properly how it works. And frankly, the amount of code you need to write is really minimal. I mean, it's hardly anything, honestly. And it means I can write them to behave exactly the way that I want. And I can create my own custom monads with as many branches off from the original as I want. So, yay. But if you just want to use a third-party library, then go for it. This one seems pretty good. I had a play with it. This is an example of a monad here. It's pretty similar to what I did, except you use maps instead of binds, and then it collapses out to a match at the end. And the match is what you need to use to define what's the final return value. So yeah, absolutely. It's otherwise mostly pretty the same. Further reading for the C# topics. So the best flipping programming book that I have read in a very long time is Functional Programming in C# by Enrico Buonanno. It's published by Manning. The 2nd edition is now out. I think it's just in pre-release form, but still, this is an amazing book, and I strongly recommend going and checking out. Some of the examples in the lecture that I've just done were based on his examples in the 1st edition. I haven't managed to get my hands on a copy of 2nd edition yet, but I will be. It's a very, very good book. There is a functional C# published by Pact by, forgive me if I'm not pronouncing this right, Visnu Angoro. That one's pretty good. I liked that one as well, but honestly, I like the Buonanno book a lot more. There are talks, in fact, this is slightly out of date because I think Kathleen Dollard there has done more talks on functional C# since. I'd recommend tracking her down. In fact, Kathleen Dollard is the person that put me on this path in the first place, and it was from her talk at NDC Oslo that I went about looking for more on this, and that's what led me to the Buonanno book. There are a couple of talks on Pluralsight. They're there. I've looked into them. They look pretty decent. And of course, you could, if you want to go really deep, you can always go for F# Fun and Profit. Scott Vlashin, that's an amazing website as well. Not just for F#, but also he's got a lot of very good conceptual articles there to understand the theory behind functional programming. And if you're really hardcore, you could always go for Haskell or something like that. I've personally never done Haskell, but I know some friends that swear by it, and sure, it's there and it does exist. So, I'm looking at the live chat at the moment. So, does anybody have any questions for me at this point? I'm happy to take any. Even if it's who is my favourite doctor, it's William Hartnell, by the way. But I'm here and available if anyone wants to drop anything.
Yeah, thank you, Simon. Thank you very much. Very interesting talk. Thank you. I had one comment to your comic strip. It should is someone using Haskell? No one ever compiles it. It's like that's the whole thing. Joking with all the Haskell people here.
I'm being a little bit mean. I've got no problem with Haskell whatsoever. I'm sure it's marvelous. It's just, but I'm a .NET developer, so yeah. it's like a big thing to pick up an entire new programming language, and also I'd have to convince the whole rest of the team to pick it up as well.
Yeah.
So it's probably not a thing I'm ever going to be able to do in production.
No.
Not that I wouldn't. It's not that I'd say no if someone asked, but I just probably won't get the chance.
So you said you went to like a presentation, the NDC in Oslo, and then you started using functional programming?
Right, yeah, that's pretty much it. I was kind of aware of functional programming prior to that. I knew it was a thing. I tried reading some explanation articles. Now, I made the huge mistake of trying to start on Wikipedia. Now, yeah, now I'm not a mathematician. I'm an engineer, and I need an engineer's explanation. And an engineer's explanation is what's it do, what's it for.
Yeah,
And
I kind of agree with you.
Wikipedia tends to be a little mathsy, a little bit like, f of g is f of I don't know, and it's all sort of like, oh, I don't understand any of this. Why are my ears bleeding? It's good stuff, and I really wish I did understand that sort of stuff, but I don't. I'm an engineer.
Yeah. Yeah.
Oh,
Had it
someone has
helped you in
asked.
any way? Yeah, sorry. Let's
Yeah.
see.
Yeah, someone. I've got a question. I got a question. Thank
Oh.
you. Have I ever used F sharp in my projects missed with C sharp? I haven't, but I have worked on with people who have, and so far as I'm aware, it's a marvelous thing to do. Um, I mean, I know that the F sharp guys are going to swoop in and say you can do everything in F sharp, and that's completely true. But honestly, I think where F sharp is really happy is like crunching numbers to numbers and classes to classes and all that sort of thing. It does it so much better than C sharp, and that's kind of maybe one option you've got. The only option with the only problem with F sharp as a .NET developer, and again, I'm like checking around for the F sharp guys at the moment because they're zooming in. I think they know where I live by now, and they're coming for me. But but the only problem is all .NET developers know C sharp.
Yeah.
Awful lot of us know VB.NET.
Mm.
God help you, and not so many, relatively speaking, know F sharp. I would have no problem if my boss turned around and said we want to do F sharp. I'd be on board for that. But I think it's a bit of an ask for an awful lot of .NET teams because you've all got to be on board with supporting F sharp.
Yeah.
But yeah, so far as I'm aware, F sharp, if you mix it in with C sharp, I think you just basically get a library full of static functions, and those are F sharp. But because it all compiles to the same common language runtime, you're getting the same basic stuff. So of course it all interops perfectly. C sharp sees F sharp libraries effectively as being the same as native C sharp libraries, so there's no problem there. And it's probably a really good idea. I personally haven't done it, but I would have no problem with doing it.
Another question. Would you say you become a better programmer when you start learning functional programming? Have your code become
Totally.
better? Yeah.
Yeah, absolutely. I mean, if for no other reason that, like I said before, I am really, really lazy. And I don't want to write a lot of code. I like to write as little code as I can get away with so long as it meets all the objectives, and functional's much better for that than any other paradigm on the market. Well, there's only two of them. But of the three that I'm aware of, functional is the most concise. It tends to be the most reliable because the other thing I don't want to have to do is spend an awful lot of time maintaining it once we start getting things like null exceptions and all the rest of it. And generally speaking, your functional programs tend to be an awful lot more robust than your non-functionals. I mean, I think there's a couple of the pure functional language out there that got the claim that once the thing actually compiles and runs, like there is nothing going to kill it, no matter what. And I believe it. I totally believe that. I don't think that's a goal we can achieve in C# for various reasons, because we have to make compromises. But it's not a bad thing to get as close to that as possible. And certainly using things like your monads there, putting a try-catch effectively in every single hop in the chain, then we're getting really close to the goal of never have another error ever again, which would be the developer's dream. Because what's the problems that we tend to get week 1 and week 2 into production? Null exceptions, unhandled. That's it, unhandled exception. Yeah, you tend not to get those. And by having like something like a maybe monad returned out of your function, it's forcing you to acknowledge the fact that this might not actually have a value. You have to do something. You can't just trust that it has a value, because that's not the way it works. So it's forcing you to be a more robust programmer, and that is good.
Yes. Then one more question. You're lazy, so what will happen? Everyone will go into functional programming, and then you will do functional
What if
programming
everyone?
level 2.
I
Joking with you.
suppose. I suppose, yeah. Why not? Functional programming 2. This time it's personal.
Thank you very much. I don't have any more questions. I'm checking the chat. I don't see any more questions. Then thank you very much, Simon. We will post everything on the YouTube channel. We'll post the links. Send them to me. If you had some links to different pages, sites you want us to show, Simon, I will flip it over to you.
But the books that I put up, those are the main things I'm interested in. But other than that, go kväll.
Yeah, go kväll. In Norwegian.
Oh yeah. Apologies.
Yeah, no worries. Thank you very much for staying with us tonight. We'll be back actually already on the 16th of June. Then we will have 2 speakers. Jane Valerud will come, and Johan Bevermyr will come and do presentations. You can check the presentations in the meetup page. Otherwise, thank you for tonight, and have a nice evening. And again, thank you very much to both of the speakers. Great presentations. Thanks, and goodbye.